Let's have example 5.6 from your handouts. Solve for all member forces. E is 29 times 10 to the 3 ksi. Moment of inertia is 88 inches to the fourth for all members. So this is an example with support settlements. Support C settles 0.2 inch. Compute for all member forces. So this is the original horizontal line. And C settles 0.2 inch. Remember that the fixed end moment due to side sway is negative 6EI delta over L square from fixed end moment formula by slope deflection equation. To derive this formula, you just treat theta n and theta f as all zeros. So due to settlement alone or side sway, 2EI over L times negative 3 delta over L is negative 6EI delta over L square. Where delta is positive if the rotation of the segment or beam is clockwise, and it is negative, delta is treated negative if the rotation of the chord joining the supports would be counterclockwise. Since there are no loads, the only fixed forces would be due to these fixed moments and the associated reactions. So fixed moment AB, there will be no fixed forces in AB. There are no loads and no settlement, only for BC. So for BC, negative 6, this is EI, 29 times 10 to the third KSI, times 88 divided by 120, span 10 times 12 is 120 inches square. Then settlement point 2 is treated positive because the rotation of BC is clockwise. But the result is negative. But negative moment in slope deflection equation means it is counterclockwise. So that's counterclockwise. Negative fixed moment. So I'll now make it positive because I put the original direction. For CB, on the other hand, that's the same, counterclockwise. Counterclockwise also. So the fixed force or reaction at B is upward. So fixed moment CB, on the other hand, because the rotation of the chord C to D is counterclockwise, then point 2 is treated negative. The result is positive, and the positive moment means clockwise by slope deflection equation, as well as BC. It's also clockwise. They're the same. So for FBR, summation moment about C0, FBR times 120 inches. Remember that we have to change this to inches. Then it is equal to 638 over 3 plus 638 over 3. So FBR times 120 equals 638 over 3 plus 638 over 3 because these are all clockwise. So FBR therefore is 319 over 90 kips. Then FCL would be, by summation forces, FCL should be downward or negative 319 over 90 kips. Likewise for FCR, summation moment at D0, FCR times 96, since the moment is clockwise also for the couples. So plus 795 over 24 plus 795 over 24 equals 0. So FCR is negative 6.92274. But I assume it is upward, but we have to take the sign negative. So therefore, FD left is positive 6.92274. So at node 2, because this is counterclockwise, the nodal load is clockwise, and it is equal to 638 over 3. At node 3, For C, this is clockwise. 7975 over 24 is clockwise, then minus counterclockwise. Moment BC, which is 68 over 3, the result is positive. So 957 over 8. Again, to get 97 over 8, it is 975 over 24. 7975 over 24 minus 638 over 3. The result is 957 over 8. So it is opposite because we take clockwise positive minus counterclockwise. And the result is positive. So that means the net fixed-in force is clockwise. But the nodal force is opposite to that result. So it is counterclockwise. 957 over 8. Then we are interested of the nodes 4 and 6. So this is just 2 by 2. But this is the stiffness of AB, 12 times E, 29 times 10 to the thirds, times 88 divided by 150 times 12, 180 cubed. So that's the result. Then 6 EI over 180 square. This is the result. Then negative of the first. Copy the second. Bring this value. This is 4 EI over L. And L is 180 inches. That's the result. The negative of this value. Then half of this value here is there. Then the negative of the first row, which is this. This is second row with columns 2 and 4 values interchange. KBC on the other hand is 12 over 120 cubed, the first term. So 12 times 29,000 KSI times 88 divided by 120 cubed is 319 over 18. 6 times 29 times 10 to the 3 times 88 divided by 120 square is that's the result. Then the negative of this first, then copy the second, that one. 4 EI divided by 120, that's the result. The negative of 3190 over 3, then half of 255200 over 3 is this. Then the negative of the first row, second row with columns 2 and 4 values interchange. Then for CD, 12 times 29,000 times 88 divided by 96 cube. 8 times 12 is 96 cube. That's the result. 6 times 29,000 times 88 divided by 96 square. That's the value. The negative of the first. Then copy the second. Copy. 4 times 29,000 times 88 divided by 96. That's the result. The negative of that value. Then this is half of this value here. Negative of row 1, then row 2 with columns 2 and 4 interchange values. So that's it. Then for the global forces, we have negative 638 over 3 and positive 957 over 8. Then this is 4, 4, we have 510, 400 over 9 plus 255, 200 over 3. We will get that value. 4, 6, there's 2, 4, 6 here, only here. 4, 6, 1, 2, 7, 600 over 3. 6, 4, 1, 2, 7, 600 over 3. Then 6, 6. We have 255, 200 over 3 plus 319000 over 3. The answer is 191400. So solving for U4 and U6, the inverse of this 2 by 2 matrix times this first matrix here. So we will get U4, U6, which corresponds to theta B and theta C, equal to negative 1.808036 times 10 to the negative 3 radians and 1.026786 times 10 to the negative 3 radians. The units would be radians automatic because EI is already incorporated. It's theta B and theta C. For the member forces, for AB, these are the forces P1, P2, P3, P4, but I replace it with their appropriate designations. Then, because only U4 has displacement, so we shade the first three columns. Fixed forces in AB 0, so 12760 over 27 times U4, which is negative 1.808036 times 10 to the negative 3 radians plus 0 equals negative 0.8548. And I want you to distribute that. These are the results. For member BC, which is 3456, we had two values, U4 and U6. So we shade columns 3 and 5. And fixed forces would be BC. We have counterclockwise 638 over 3, positive. At the other end, counterclockwise also 638 over 3, so positive. For FBR, it is 319 over 90. FBR upward, and FC left negative 319 over 90. So that's why you get this value. Then for CD, 5678. So we copy the stiffness, which is this. Only U6 will have a value 7 and 8 zeros. So we shade 5, 7, and 8. So this is the active column 39875 over 24 times 1.026786 times 10 to the negative 3 radian, plus the fixed in force, which is FCR, and FCR is negative 6.92274. You will get negative 5.217, and same is true for the rest. These are the values.